Hi, welcome back to Science 1206, the motion unit. In this lesson, we'll talk about scientific notation. Let's get started. What is scientific notation? Scientific notation is a way of expressing numbers too large or too small to be conveniently written in decimal form. For example, 2 million can be written as 2 times 10 to the power of 6 in scientific notation, and 0.000000025 can be written as 2.5 times 10 to the negative 8. Scientists, such as astronomers, often encounter very large numbers. For example, Neptune is 4,495,100,000 kilometers from the Sun. Microbiologists, on the other hand, come across very small numbers. A red blood cell, for example, is around 0.000007 millimeters. Writing these very large or very small numbers in scientific notation helps avoid mistakes when writing the numbers and makes calculations easier. In scientific notation, a number is expressed as a product of two parts, a number ranging from 1 to 9, and 10 raised to a certain power. For example, 10 to the power of 5. This is read as 10 to the power of 5. It means 10 multiplied by itself 5 times. That is 10 times 10 times 10 times 10 times 10, which is 100,000. For large numbers greater than 1, this power of 10 has a positive exponent. For example, 4.504 times 10 to the power of 6 is 4,504,000 in standard notation. Meanwhile, the exponent is negative for small numbers less than 1. For example, 2.34 times 10 to the negative 3 is equivalent to 0.00234. What is standard notation, which I just mentioned? Standard notation is the way we usually write a number using digits. For example, 3.54 meters, 56 seconds, or $25.99. Standard notation is most useful when dealing with numbers that are not too large or too small. For example, when identifying the price of something in a store, reporting the number of students attending school, or the distance you drove on vacation. Now let's look at how to convert from standard notation to scientific notation. Our first example asks us to write 341,717 in scientific notation. If there's no decimal in the number, the decimal starts at the end of the whole number. So we'll put that in. Next, we're going to move the decimal to the left until we have a number that's greater or equal to 1, but less than 10. And we need to count the number of spaces that we move the decimal because this is going to be our exponent. So we're moving the decimal 1, 2, 3, 4, 5 places. 5 is going to be our exponent, and our decimal is going to move to between the 3 and the 4 because that gives us a number that is greater or equal to 1 but less than 10, 3.41717. So our answer then is 3.41717 times 10 to the power of 5. When the original number is greater than 1, like this number was, 341,717, the power of 10 has a positive exponent. We moved our decimal 5 places, so our exponent is 5. Let's look at another example. In this example, we're writing 0.0000000000053 in scientific notation. And you can see why it would be convenient to put this number in scientific notation, because it would be so easy to accidentally leave off a 0 or make a mistake using this number in calculations. So the first thing we're going to do is move our decimal. In this case, the decimal is already present. And we're going to move our decimal to the right this time until there is one number that is not 0 to the left of the decimal point. As we move, just like we did before, we're going to count the number of spaces because this is going to be our exponent. So we're going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to the right. That'll give us a number 5.3. So our answer then is 5.3 times 10 to the negative 11 because we moved 11 spaces. And when the original number is less than 1, the exponent is negative. We moved 11 places to the right, so our exponent is negative 11. Now it's time for you to do some practice. Pause this instructional video and grab a pencil and some paper or open up a blank document on your electronic device. Number your paper or document from 1 to 5. As each problem in the table on the next slide is revealed, write down your answer and then we'll review the correct answers one by one. After you number your paper or document, please resume this instructional video. For our first problem, you're going to convert 456,709 meters into scientific notation. Be sure to pause this video while you do your workings and then resume it to see the answer revealed. So our answer is 4.56709 times 10 to the power of 5 meters. In this case, we moved our decimal to the left until we got a number between 1 and 10, counting as we moved, and we moved 5 spaces. Our next problem is 8,545 kilometers. And our answer is 8.545 times 10 to the power 3 kilometers. Again, there was no decimal, so we put it on the end, and then we moved the decimal to the left until we obtained a number between 1 and 10. We counted our spaces as we moved, and we moved 3 spaces, and that's where the exponent 3 came from. Our next example, we have 0.000000345. Give that one a try. And our answer is 3.45 times 10 to the negative 7 meters per second. So we moved our decimal 7 places, but in this case we started with a number below 1, so our exponent is negative. And we moved our decimal until we had a number in front of the decimal that was greater than 1, which was our 3. Let's give this one a try. 0.000769 millimeters. And our answer is 7.69 times 10 to the negative 4 millimeters. We moved our decimal 4 places to the right, and that's where our exponent negative 4 comes from. And our last example for you to try is 0.000000032 seconds. And our answer is 3.2 times 10 to the negative 8 seconds. We moved our decimal 8 places to the right. Next, let's take a look at how we go from scientific notation back to standard notation. To convert from scientific notation back to standard notation, follow these steps. Look at the exponent on the 10. This will determine how many places you need to move the decimal point. If the exponent is positive, we'll move the decimal point to the right since you're working backwards. This is the opposite of what was done to create the number in scientific notation. If it's negative, then move the decimal point to the left, the opposite of what was done to create the number in scientific notation. As you move the decimal point, fill in any empty spaces with zeros. Once the decimal point has been moved to the correct number of spaces, you have your number in standard notation. Let's look at a couple of examples. Our first example asks us to write 3.9 times 10 to the power of 4 in standard notation. The exponent on the 10 is 4, so we need to move the decimal point 4 spaces. The exponent is positive, so we are moving to the right. We're doing the opposite of what was done to put the number in scientific notation. Remember that we need to fill in any empty spaces with zeros as we move. So we're moving 1, 2, 3, 4 spaces to the right as indicated by our exponent, 4 spaces, and then we need to add some zeros here. We have 3 empty spaces. We will need to add 3 zeros. Our answer in standard notation is 39,000. Now it's time to review. Please complete the learning activities in Brightspace.